Can you solve this problem? The problem that you saw on the title screen, we're going to put it back up again, read through it together, and that'll be your cue to pause it there, work out the solution on your own if you want, because right after that we're going to dive right into it. The most important thing I think about problems like this is not the answer that we arrive at, it's the process that we go mentally. How do we systematically think about solving problems like this that might seem really difficult at first, but there's a way to make them simple. So before we get too far in, I'm going to put that problem up right now. All right, here's that problem again. Take an opportunity to pause it because we are going to dive into the solution right after that. In 3, 2, 1. Welcome back. I hope you had fun trying to solve that, and if you decided it wasn't worth your time, or you thought it was too complicated, or you gave up somewhere in there, we're now going to go into the solution, and if you did solve it, let's see if we arrive at the same answer. Now, the most important thing, as I said, in how to think about this problem is not to take a complex problem at its whole. You have to break it into parts. A lot of people just read right through it, start trying to take in and process all that information at once, and it just seems like a lot. So we break it into the things that we know. I've done that by writing a few things up here on the board to save a little time. But you can see that I've written down our sequence, our code of 5 numbers from x1, 2, 3, 4, 5. You could have had A, B, C, D, E, F, whatever you want. I've chosen that because this helps us keep track of what number we're talking about. Oh, and just for you computer people out there, I am working in base 1. This is not the 0th element. Nerd alert. But we also know from the word phrases there that we have these 3 equations that they gave us, where x1 is equal to 3x5, x3 is equal to x2 minus 3, x4, x2 plus 4, and the other thing that they said was that 3 of the pairs totaled up to 11. So that means x5 plus x3 has to equal, or x4 plus x2, x1 plus x5. We have to have 3 pairs of numbers that add up to 11. So I wrote out the pairs that you could possibly have to make 11. And the other thing, I think it should be obvious, but I'll state it anyway, is that it has to be a single-digit number. It's a sequence of 5 numbers, not more, so any x has to go from 0 to 9. So not less than 0, not greater than 9. Those are important facts that we will use. All right, let's write down, and I've written these out there very specifically because essentially these equations kind of all go together, and this goes together. So let's look at possible outcomes. We know that x5 could be 0, that makes 0, 1, 3, 2, 6, and 3, and 9. And we can stop right there because if x5 were to be equal to 4, then x1 would be equal to 12. And you can't go any higher than that. So these are the possible combinations that we can have. Now, the other thing that I did notice is that none of those add up to 11. So it means that these have to be paired with something else from here unless these somehow all equal 11 if you pair them up right. All right, the next thing that we know is x2. So x2 minus 3. That means x2 can't be any smaller than 3 because that would be a negative number. So x2, our first x2, is 3. And that means x3 is 0, and x4 is 7. Now you can see that we're going to get another pattern here where we go to 4, 1, and 8, 5, 2, and 9. Now we can't, again, go any higher than this because if we were to do that, obviously x4 would be greater than 9. So we know that these would be the different pairs of variables. Now we can see that any of these on its own can't add up to 3 11s. So we're just going to say that solution doesn't work. So let's say what is the first sequence? Well, we can say x1 is 3 and x5 is 1. So we could try 307. Now it seems pretty obvious that nothing is going to total up to 11. So if we continue that general thing, we would see that, well, you don't really get any luck with this on any of this. So you have 3 plus 8, that's it. And then you have 9 plus 2, and that's it. So 3 and 1 doesn't work. Now let's try 6 and 2. So we have 6 and a 2. So looking here, do we get any pairs on this row? No. How about this row? So do we get any pairs of 11? Nope. How about this row? Do we get pairs of 11? The answer is yes. We have 6 plus 5 is 11. We have 2 plus 9 is 11. And 9 plus 2 is 11. That means we can stop there. And that is the answer. So as you can see, what I've really done is taken what might appear to be on the surface a complicated problem, and rather than trying to take it all in at once, I broke it down into sequences, starting with what I know, defining that, and then reduced it to a solvable number of options that we could then use to arrive at the right sequence for the solution. So just to test that out, if we want to test it out, you know, we already know that we have 3 11s. x4 is equal to 5 plus 4. x3, 5 minus 3. And 3 times x5 is 6. All right, happy times, good times. That is the answer. I hope you had fun solving it, or if you didn't, I hope you appreciated learning a little bit more about the structured way to think about solving any complex problem.